Hello everyone, welcome back to this lecture. I hope you are well. In previous lecture, I discussed about different types of data where I discuss about the structured data that can be represented in the form of tabular, which consists of rows as well as columns. No, and second type I discussed, that is unstructured data that does not have a predefined order, which like images, audio and video and text. No, when we write an article and anything. So this is a part of the unstructured data. Third is semi-structured data, where which consists of both structure as well as unstructured data. Like it has a metadata tags in their dataset. Fourth is a time series data, which incorporate the times, which is important when we are building a AI model which work for a weather forecasting as well as stock price analysis. So in this lecture, I will discuss about the different types of data set. This concept is very crucial when we are building a career in a machine learning. This lecture looks like a very simple, but this lecture play a crucial role, and this concept and their fundamentals play a crucial role when you build a large, scalable, and efficient machine learning model. That's why I am giving a more lecture on a foundation before explaining the complex machine learning algorithm. Let's start this lecture. If I talk about the there are four primary data set, uh, three primary data set, that is training data set, validation data set and test data set. uh, I show you the one diagram here. This is the whole data. This is the whole data set, uh, which we pre-process and do the lot of methods, apply methods, so that we can feed into the model. So this process we are doing before feeding the model. So we have a data set. We are trying to splitting the data set into three steps. Like we have a training data set, which is consist of 80% of data, and we have a validation data set, which consists of 10% of data, and we have a 10% of data which have a test data set. I think it will take a time, so I will explain. So we have a data set. We split the data set into a training, validation, and test data set. In training data set, we actually use the large amount of data set to train the model. In training, what happen? We are trying to optimizing the parameter. We are trying to getting the weights and biases, which we call a parameter that are learned when we train a model. And in a validation data set, we during a training we fine tune the hyperparameter like learning rate, number of layers. If we are working building a CNN based model, CNN nothing but convolutional neural network, which is used to capture the images features. And third type is test data set, which is used to evaluate the performance of the model. You have built the model and fine tune the hyperparameter. You need to check our model work well on the real data or not. So we need to evaluate the model. So we use the test data set, which is unseen data set, and we can check the model is generalizable or not. So let's go into deep. I written a here. you will see the training dataset. Here it is the largest and most important dataset used to train the ML model, as I discussed earlier. Here, here model learn from the data. Here model learn from the data by adjusting its parameter to minimize the error. In the training dataset, we feed the large amount of data. During training, model try to optimizing the parameter, changing the parameter so that we get a very less error, and we capture the pattern which is present in the dataset. For example, if you are building a house price predictor model and you choose a feature like area, number of bedrooms, etc. So you feed the large amount of data in your training. Here model try to optimizing the parameter, means you are changing the adjusting the parameter accordingly over the data set to minimize the error. In a second example, if you are building a spam detector, here you will feed emails as well as labels, uh, and model try to learn the pattern and try to adjusting the parameter to minimize the error. Let's move to the during training, we also do one more thing, like in a validation data set, we fine tuning the parameter during training only. We adjust a parameter that is called weight and biases, but we also feed the validation data set which help to fine tuning the hyperparameter like learning rate, number of layers, which help in avoiding the overfitting problems by ensuring the model perform well on the unseen data. You have a X-ray image and you are trying to detect a disease, person is healthy or not, and you try to fine tuning the hyperparameter so that you avoid the misclassification. And you are seeing the some word like parameter and hyperparameter. First, I will distinguish between the parameter as well as hyperparameter. Parameters are those parameters, those values that are trained, that are learned during the training. Hyperparameter are those value that are set before the training that will not change during the training. That is the key difference. Please pay attention over it. And let's move to the test data set. We have trained the model as well as fine tuning the hyperparameter. We need to check it our model perform well on the unseen data set to have a generalizable model. So we feed the test data set. That data set are not seen during the training because we kept away from the training. So model never see the data during the training and ensuring the unbiased performance check. If you use the data, if you test the model using training data set, so it will not give you a actual picture because you are using the same data. If you give a test data set which is unseen, which is not used during training, so it will give you a clear picture of performance of the model. For example, you are building a fraud detection for a banking sector. You have a transaction. You need to test the model on the new transaction, not the data set which is used for training. Okay, like you have built a voice assistant and you want to check the accuracy of that. So you need to check using a with the real user voices. Okay, so we have seen the there are the three types of data set which is primarily used in a machine learning. Now, before feeding the data set, we need to split the whole data set into the training, validation, and testing. There are a few other types of data set also there. I also want to explain because that terms will be repeatedly used or frequently used when I explain the complex algorithm and concept of machine learning. So I want you should make a sense when I discuss when I mention the label data set, so you have a understanding what is that. So let's start the label data set. Here it contains the input and correct output labels. Here dataset are the format of XY format having input output pair, which we have seen in the supervised machine learning. in a previous lecture. If you have not seen, please see this lecture. Then watch the supervised machine learning lecture, which is very impressive lecture. You will get a more intuition about the what is the supervised machine learning. I give a lot of examples. So in a label data set, we have an input output pair, which is generally used in the supervised machine learning, where we have a two major tasks: regression task or classification task. And that it helps the model learn the patterns to predict the outcomes. For example, if you're building a AI model which detect the given email is a spam or not, so you feed the data set first, like email one having a their label is spam or not. Yeah, first is spam, second is not a spam. Have a number of training examples and corresponding labels. You feed into the model, and so this data set is called X and Y or label data set. Okay, this is a example of classification problem because we have a categorical target variable. If you're building a sentiment analysis of customer review, so you have a customer review corresponding labels like positive review, negative review, or neutral review. Yeah, if you're building a AI model to detect a uh, based on the image feature, patient having a cancer or not, so you have a label as well. So this is an example of the labeled data set. We have a input as well as output pair. Let's move to the other type of data set like unlabeled data set. Here its name tell about this data set does not have a labels. So it only have a input data. It has a input data. It has only X. There is no Y. So this term I also use when I'm giving a I am discussing the unsupervised machine learning. Where what happened, they don't have a labels like we have in a supervised machine learning and label data set. So they only have a input data. They try to find out the pattern which is present in the data set. They try to find out a structure present in the data set, and uh, without explicit supervision, as this thing happen in the label data set. For example, you are building AI model which is used to segment the customer based on the shopping behavior for no personalize the recommendation for a product. So you do the clustering algorithm, K-means algorithm. There are a lot of algorithm are there. I will discuss in upcoming lecture. Yeah, you have a data set which is anomaly, like which deviate from the normal behavior of data set. So you can detect like in a network security, you need to detect the anomaly to prevent the integrity of the network. And next is the imbalanced data set. Here, one class having a larger training examples. Training example nothing but we have a large number of rows, large number of samples. We have a large number of training example for a one class than other. So it will lead to a biasness in model. I will take example. Suppose let us consider a scenario where you given a task of building a AI model. You need to detect a uh, given transaction is a fraudulent or not, like legitimate or not. So you must first uh, pay attention over the what is the how many sample of the class 1, class 2, class 3. If here there are two class, legitimate class and fraudulent class. So I take example of 99% of data set we have a legitimate, there is no fraud, but only 1% of data set we have fraudulent, there is a fraud. So model might predict the most transaction as a not fraud because fraudulent case are rare, because we have given a 99 we out if I take a 100 sample we have, so 99 data set are the legitimate, only one are fraudulent. So model might be any transition, it will predict the legitimate transition. It will lead to a biasness in the model. That is not good for a machine learning practitioner. So how to solve this problem? For solving problem, we need to oversampling of minority class. Minority class here is fraudulent samples. So we need to increasing the to match with the class 1 legitimate samples. Like we have, if I have a 100 sample, and 99 are the legitimate. So we need to create the 98 more sample of fraudulent so that our model become a more robust to handle the any type of transaction. It is provide a better output. And in a detecting a rare disease, same thing happen because we don't have a large amount data of the rare disease. Its names indicate is a rare. If you have a common disease, so you have a large number of sample, but we don't have a large sample. It will lead to a biasness in the model. So you need to correct it through oversampling of the minority class. There are a lot of solution are there. First, you need to consider oversampling of minority. Oversampling thing, but we are increasing the samples. How to increase it? We are trying to creating the number of samples. Okay. So let's move to the balanced data set. A data set where each class have an equal number of samples. Here there is no problem of like happen in the imbalanced data set. So like for example in a sentiment analysis we have three class: positive review, class means labels, positive review, negative review and neutral review. So we have a equal number of sample like 100 sample, 100 sample, 100 sample. We have a 300 total data set and 100 sample for each class. So it will give you a unbiased model performance. Same example for diagnosis of common disease, have a pneumonia and other disease also. Uh, Time series dataset which incorporate the time, which is very useful for when you are building AI model for a forecasting purpose of weather, yeah, in finance sector, in healthcare sector. You need to consider the previous history of the patient. Then you will able to take intelligent decisions based on the patient history, as well as climate prediction as well. If you are building a making a AI model for a climate, and you need to take a data over period of time because every period of time differ. So you need to take into account. So time become a more useful when you are building a model for forecasting, finance, and healthcare, and climate prediction. Like stock market analysis, we need to incorporate a time. Open dataset are the publicly available dataset, free to use dataset for ML researcher and development. For example, Kaggle dataset here, UCI ML repository, which having a large dataset in every domain like medical industry, any healthcare. You will find a large amount data set of any every domain. Having an image data set, if you are building a AI model which work for a image recognition, so you need an image data set to use the ImageNet data set. That data set can be used for a ML research purpose, not for commercial. Synthetic data set are used to because we know data set is rare. We cannot get is a data set. A data set is scarce. So how to we generate data set? So we try to generate data set through the AI models. They generate the synthetic data set which can be used to build the AI model which become more robust. Like if you are building a customer review model and you have a few samples, very few samples you have, so you need to create a fake customer review sample to train the model that can be performed better than earlier model on an unseen data set. It become a more generalizable. So synthetic data set become a need of our in our machine learning field because data set cannot be get. It is very difficult to get. So we need to create a synthetic data set. So in this lecture, no, I discuss different type of data set. First, is training, validation, and testing data set, which are the core of the machine learning. And I discuss open data set and time series data set, balance, imbalance, which is very important terms, and labeled data set, unlabeled data set. And I hope you understand this lecture. Still, if you have any query or problem in understanding this lecture, please leave them in comment section. I'm happy to resolve this problem. And thank you so much, everyone. See you in next lecture.